Okay, ji. So differentiation AS lecture 3. We have already covered what is differentiation and how the question will be tested by the examiner in lecture number 1. We covered down the rules that are used for the derivative in lecture 2. Today we will be working on stationary point, which we have already discussed that it's more of maximum and minimum point. The stationary point is maximum point and minimum point, and this will be always used as dy upon dx is equal to 0, because at the point, stationary point, when we talk about our U-shaped curve, or we could talk about our N-shaped curve, the tangent gradient or the tangent is basically parallel to the x-axis. When the tangent is parallel to the x-axis, so we always know that x-axis gradient is 0. So tangent gradient will be 0. So with respect to that stationary point, gradient will be 0. Moreover, the question also talks about, or the subtopic that we will be knowing is rate of change. Now, rate of change in AS is basically corresponding to the time taken for change. Now, let's say that you have a point of x and y. Now, in this, you've got a curve. A curve does not have gradient, but it has a gradient for its point and the tangent, right? So at this point, you need to understand the rate of change in the gradient for particular points. So how much time will it take? So that means there would be dy upon dx. There would be dy upon dx when you solve what equation of the curve for its gradient. This dy upon dx is basically the gradient at any point of x. Any point of x. So specifically, what you need to understand is that when we have dy upon dx, this dy upon dx is compared with time. That means dy into dx. And one thing that is introduced is dt. What is introduced? dt. That we may introduce dt in the numerator, we introduce dt in the denominator, but what we did was we actually separated dy and dx. We kept dy in numerator and we kept dx in denominator, but in the separate fraction introducing dt and dt. Now what does, since dy upon dx represents the gradient at that point, what does dy upon dt represent? dy upon dt represent change in y with respect to time. With respect to time, there will be so as I said that if the question says rate of increase in y, so that means dy upon dt. If the question says rate of decrease in y, this would be negative dy upon dt. If the question says rate of change, rate of increase in x, so this will be dx upon dt. And if the question says rate of decrease in x. So this should be negative dx upon dt. So your increase shows the positive change, your decrease shows the negative change. Now, it is not necessary that it is always dy upon dx. The question can also be linked to dA upon dx. So this should be dA upon dt into dt upon dx. If the question is about volume, so this would be dy upon dx. So at this would be dy into dx, and what will you introduce? Dt, dt. It will be introduced at dt and dt. So if we try solving few examples of this, it will get easier. So we have question from June 2002, paper 1, question number 9. Let's say the curve is such that the dy upon dx is 12 upon 2x. Now this dy upon dx means that it has already been differentiated. That means y has already been differentiated, and you have this equation. And P is 1, 5, and point of the normal to the curve at P crosses x-axis at Q, find the value of Q. For part 1, you will have to make sure that you use x is equal to 1 to find the gradient, and that gradient will be reciprocal with negative sign to have the gradient for your normal, because normal is perpendicular. Using the point of P, you find out the equation of normal, and then that equation of normal will be crossing the x-axis. That means y will be 0, you'll find the q. But at the moment, what important is part 2. The question says a point is moving along the curve in such a way that the x coordinate is increasing at a constant rate of 0.3. So that means the x coordinate and increasing at the rate. So that means they are talking about dx upon dt. They are talking about dx upon dt, which is 0.3. Find the rate of increase of dy y coordinate. That means the examiner wants us to find dy upon dt. So the information that is given is dy upon dx is given 12 to 1 plus 1 whole square. So this means 3 whole square is 9, 12 upon 9. So this should be 4 upon 3. So the gradient at x is equal to 1 is 4 upon 3. Then you know that dx upon dt is 0.3, and you are not aware of dy upon dt, which you need to find. So find the rate of increase of dy upon dt. So dy upon dx at the rate of when x is equal to 1 should be dy upon dt into dt upon dx. This will be your formula. Now we know that when x is equal to 1, 4 upon 3 is the gradient. You do not know dy upon dt, but you know dx upon dt. But in this, you have dt upon dx. So this should be 1 upon 0.3. 1 upon 0.3. 1 upon 0.3. 4 multiplies by 0.3 divided by 3. You will get dy upon dt. The answer for this, when you multiply 4 into 0.3 is 12 into 10.